Hey everyone, it's Mr. Canfield. Today we're doing 7-4 right triangle similarity. So if you take some right triangle, any right triangle, and you drop an altitude, what we're going to see is that if we took these triangles and we broke them up like this, well, look at what we have here. We have our original triangle with a double line, a single line, and the right angle. And then we have this triangle over here. We'll call this triangle, we'll name it in just a minute. But see how it has the double angle and the right angle? This has two angles that this big triangle has. If you remember back to similarity types, a similarity said as long as they shared two angles, then the two triangles were similar. So the big triangle is similar to this one. So if we're going to name this carefully, this says ABC like that. It goes double angle, single angle, right angle. So to name this correctly, I would need to go double angle, single angle, which I can't see, but I guess it'd be that one up there. So double angle goes first, single angle next, right angle last. So we know triangle ABC is similar to triangle ACD. Let's see, what about this? With this one, it's the same story, right? It's got the single angle and the right angle. This whole thing has a single angle and the right angle. So these two triangles are similar. Well, if I say this is ABC, I start with the double angle, which is not known on this one, so it would be C. Move to single angle, which is B. And then right angle last, which would be D. So, but here's the crazy thing. Since triangle ABC is similar to both of those, because it shares two angles with that. Remember, if it shares two angles, it does share the third angle. We just don't call it that. We don't say it's triple A similarity, we say it's double A similarity. So, but because of that, we can say, oh, I forgot the triangle there. We could say triangle ACD is similar to triangle CBD. And this should work out, right? This should be double angle first, which double angle, double angle. Second one, let's see, that's the single angle, right? Single angle, and the last one is right angle. The order worked out. This always happens. Any right triangle ever. You take the right triangle, you start at the right angle, and you drop an altitude down to the hypotenuse. Works every time. And that's like today's lesson is gonna revolve around this idea that we have similar triangles. And we're just gonna be doing lots of proportions. So it says, given that PQR is similar to QSR, what is QS? So again, this is one of those things where if it's helpful for you, you can just draw a triangle, PQR, QSR. I actually like to do this without drawing the right angle. For some reason, my brain locks up if I don't draw it that way. So PQR, let's see, I know PQ is 20. Let's see, QR, that's 15. Do I know PR? No, I don't know PR. And I know that Q, that's my right angle. So I'm gonna put it looks really bad, but I'm putting the right angle there. It does, for my brain, that's how I have to handle it. You might do better drawing these more looking like right triangles, but then QSR. So do I know any of these sides? Oh, I know QR is 15. QSR. Oh, I know SR is 9. Okay. It wants to know what is QS, so that's X right there, right? So here's the thing. We got similar triangles, right? So I'm just gonna set it up. Now it's very easy for me to see 20 and X go together, 15 and 9 go together, and blank and 15 go together. That's why I like to draw them like this. I just read them out in that order and I draw the same way every time. So 20 goes to X. I can say that is equal to 15 going to 9. Remember, when you set these up, it's so important that you do whatever spot you start there, that's the spot you join it with. And if you do that one over that one, you have to do that one over that one. So it's super important that we keep the order the same on these. So now I just do the butterfly. All right. Remember, all the details are very important. Just kidding, not at all. So I'll do X times 15, I'll get 15X, and I'll do 20 times 9 and get 180. And I'll divide both sides by 15, and I get that x is equal to, I think that's 12. I've already done these problems, so. 180 divided by 15, just double checking, don't trust myself. Yep, I got 12. All right, cool. So now let's use the same diagram to find PS. So now I'm using PS. So unfortunately, these two pictures are not helpful here because I need PS. So now I really do have choices. I could take the whole big triangle and then relate it to this smaller triangle here, or I could relate this smaller triangle to the one over here. And it doesn't actually matter. So I will do the left triangle to the right triangle, but I have to be careful. So if I pick this triangle, but here's 20, it might not be super readily apparent which one of these is small and long, because the small one and the long one actually matter which one you say it is. So like this is the shorter side, that's the longer side. Then over here, this is the shorter side, that's the longer side. So if I'm calling this X this time, then over on this triangle, I've got to be careful. So this triangle is kind of turned a little bit. So this was the long side on that one, and this is the long side on this one. Oh no, I don't know this long side. Oh wait, no, I just found that a minute ago it was 12. So one way I could do it is I could say X is to 12, and then 20 goes to 15. So I can cross multiply now. I get 15x is equal to 12 times 20. I get 240, then I'll divide by 15. I get x is equal to 16. So my brain's like, is that right? Let me just pull up the answer key really quick. I don't want to be making silly mistakes in this. Let's see, just double checking. Sorry about this, but just bear with me for 30 more seconds. Yeah, okay, cool. Yeah, I've done all these problems, but so now I'm getting answers from different problems popping up in my head. I'm like, wait, was that right? Okay, so that's not the only way to do that question. That was just a way to do the question. There's lots of different setups you can do for these. Okay, and now we get to the next kind of problem we're going to run into. The setup on these is so similar, but it still is tricky at the same time. So this time we're asked to find CD. So CD is x, but that's kind of weird when we go and look at the numbers that we have. So when I look at this, I see we got the little triangle and then the second little triangle. Because it's this altitude here, it's not a piece that is on the big triangle. So I can only use the two little triangles. But here's the thing, in the little triangle, it looks like it's longer, but maybe it's not, but whatever it is, let's say it's the longer side. In the other triangle, it's going to be the short side. So if I set this up carefully, so 5's the short side of this one, and maybe it would help to actually draw them. Let's draw them both like this. If I draw them both like this, I can put 5 here and then x here, right? Well, and that's going to be my A, D, C. But I have to be careful. In this one, the short side actually goes from C to D. So this is actually going to be C, D, B. And it's going to be X here, and it's going to be 15 here. So what this does is I can say, well, 5 goes to X. That was that to that. Now I have to do that to that, which is going to be X to 15. And this is the thing. You're going to see the x that we're looking for, it's going to be diagonally across from itself. When you're dealing with a situation where you're looking for one side and you only have two other numbers, this is basically how it's always going to work out. You're going to have the two numbers with x diagonally in the middle. Figuring out these two numbers is sometimes challenging, but this is the real setup. X is going to be diagonal like that when there's only those two numbers. So now I'll do the butterfly. I'll do 5 times 15, that's 75. And I'll do, oh wait, let's put it on this side. And I'll do x times x. Oh, I can't feel it. So 5 times 15 is 75, and then x times x is x squared. Now we have not dealt with this, I think, at all this school year in geometry, but the way we get an x by itself, if it says x squared, is we do the square root. And so we're going to take the square root of both sides. And what that does is when you square root a square, they're the opposite of each other, and they cancel out, and we're just left with the x. And so I can go and I can take the square root of 75, which is 8.66. I'll put little bacons to say it's approximately. So that is what we get for that x. But this setup, this is going to be our key, like basically for the rest of the problems we're doing today. That's what this theorem is talking about down here. There's something called the geometric mean, and that's what this piece has to do with. So seriously though, it always works like this. So on this one, oh, I forgot to put directions on here. This one we are trying to find ut, so let's put an x there. Literally, I could even kind of botch the startup of this and not really pay too much attention. I can go 9.6 goes to x, well then x goes to 5.4. If I do 9.6 times 5.4, I get 51.84, and that's equal to x squared, because x times x is x squared. It's not 2x, it's a different thing. So when I take the square root of both sides, I get 7.2. And that one actually looks like it's going to be exactly 7.2. So now let's move into our next question. It says, what is RT? Same triangle, but now it's asking for RT. Ooh, okay, so this is X. And so you might think it's going to be a lot different. Not so much. So let's see, what two triangles is this part of? Well, it's part of like this one right here, right? So it's part of this one, 9.6 and X with the right angle here. So what other triangle has it? Well, the big triangle. So let's draw the big triangle in the same setup, right? With the little right angle here. What's our hypotenuse of this triangle? Well, let's see. The hypotenuse of the big triangle is 9.6 and 5.4 together. Let's see, 9.6 plus 5.4 together. 9.6 plus 5.4, is that 15? It's 15. So this whole side is 15. But now I have to figure out, where does this X belong? So let's go back to this guy, and we see on this guy, 9.6 is the longer side. And then on this guy, X is the longer side. So I know X is going to go in the same place as 9.6. And so now I've got enough to do my setup. I can do 9.6 to X, and that's the same as X to 15. But really, once I found my 9.6 and 15 were the two numbers I was going to use, I can just do this setup because it's always going to work like that. But that's cheating. I shouldn't tell you that. So now I'm going to get X squared is equal to 9.6 plus 15. Oh, let's say you're annoyed that I'm not really showing. To do square root, it's right here. There's a little check mark above it, so you do second square root. 24.6, and I got 4.9598, blah, 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 blah. So take the square root of both sides. I'm going to say X is approximately 4.96. All right. Sorry for the sniffles. All right, next question. I'm trying to get through this before my planning period is over. All right, this one asks for JL. Okay, so Now I'm going to use this diagram twice, so let me be careful and not just draw on the diagram. So we'll say that's 4 and that's x with our right angle there. So if I'm trying to draw the big one, same orientation. Well, then in the big one, x is my little side here, and my hypotenuse is going to be the whole thing here. Oh, it's 4 and 20, so it's 24. So now I can do 4 to x is equal to x to 24, cross multiply, 4 times 24, you get 96, and 96 is equal to x squared. Take the square root of both sides. It's the same, it does the same thing over and over and over again. So x is going to be approximately 9.80 on this one, because that 9 gets rounded up by that 7, and then we carry it over. But now it asks me for KL. So now I'll just draw on this diagram. It's asking me for x. So it looks like I've got big triangle here. Well, medium, I guess. We got tiny, medium, and then the biggest one. So we've got the medium triangle and then the big triangle. So looks like x is my hypotenuse in this one, and 20 is my small side. And then for the big triangle, did I say small side? That's the small side. It's the larger leg. So larger leg and hypotenuse. And then if I'm using the whole thing, x is the larger leg, 24 is the hypotenuse. So I can do 20 to x is equal to x to 24, like without even really remembering exactly how stuff is laid out. Just those are the two triangles I need, those are the sides that I have there. So 20 times 24, you get 480 is equal to x squared. I take the square root of both sides. Square root of 480 is approximately 21.91. I got 908. 9089. Cool, and then in number 10, I didn't put x anywhere. So we can pick any random side, right? It doesn't matter which one you're looking for. I can look for any one of these and use the same setup as before. Just be careful with the numbers. So I'll look for this one. So I see I'm in my smaller triangle. I can do 36 to x, and then I'm going to do x to something else. Let's see. Oh, we have the big triangle, right? So I'll do x to whatever those are added up, which is 36 plus 64, right? 100. So now we'll cross multiply. We'll do 36 times 100. I get 3600 is equal to x squared. Take the square root. Looks like it's going to be 60. So x is exactly equal to 60 on that one. So this is 60. But we could have done this one here. Let's call this one y. Well, if I wanted to find that, I could do 36 to y, and then y to, well, let's see. That's little triangle and medium triangle, right? They both have it. So 36 to y, and then y to 64 would be. So 36 times 64. We'll take the square root of that one. Oh, it looks like that one's going to be, no, oh, no, all right. Y is equal to 48. Well, hey, we came this far, I may as well finish. Let's call this one z. So I could do, looks like medium triangle, so I could do 64 is going to go to z, and then z is going to go to medium triangle, big triangle, right? That's 100, so 100. 64 times 100, then we'll take the square root of it. Well, would you look at that? Z is equal to 80. So depending on which one we go for in class, that's how I would get any of them. It's nice when a triangle gets all round numbers for its answers. All right, I'm probably gonna mispronounce this, but Zhang is constructing a 4-foot-high loading ramp. So it's a little hard to see, but that's for that side right there. The length of the back of the base must be 12.8 feet. Oh, so this right here, the back, this part is 12.8. How long must the entire base be? So that's our x right there, right? That's not our answer, but we need that. So let's see. This one's a little bit trickier. So we could look at the little triangle, and then, oh wait, maybe we don't want that part. We want the whole base is x. Does that do it? Let's see. So, truth be told, I am trying this one blind right now. I didn't have time to knock this out before I made my copies and stuff. So let's see. I know I've got this triangle here, the medium triangle. Maybe I do need, I'll call this F. Maybe I need to find F first. So the problem is, the only way I know how to solve this is a little bit more complicated than anything we've done so far today. What I would say is, like I can do 12.8. To 4 is equal to 4 to F. Right, like if I'm looking at my two medium, my medium and my small triangle, I can do big goes to big, which is 12.8 to 4, and then I can do 4 is small and F is small. So I can say 12.8 F is equal to 16. 16 divided by 12.8. I get F is equal to 1.25. So if F is 1.25 and we know 12.8, then we can 1.25 plus 12.8. That's going to give us our total base there of 14.05. So now it asks, how long will the ramp be? So, not gonna lie, I would use Pythagorean theorem instead of using proportions. I'd say 12.8 squared plus 4 squared is equal to ramp squared. And I'd solve that. But to keep in spirit with the proportions that we've been doing, this is 12.8. And this is 4, and this is x. And then we have our big triangle. That's x. Oh, so like if I flip this to, and this is my short one, right? If I flip this to be the right orientation as the other one, then that's my long leg there. And we know the hypotenuse of this is the 14.05. So I would do x to, no wait, no. Which one would I do? I would do 12.0, yeah, I'd do 12.8 goes to x, and then 4 goes to 14.05. And I'd solve that one. So I'll cross multiply. I'll get 12.8 times 14.05. And that'll give me 4x, right? That way gets 4x. That way gets, so 179.84 is equal to 4x. We'll divide both sides by 4. And get x is equal to 44.96 feet. Well, there's no way that's right. Look, this is the longest side, right? That's 14 feet. 44 feet doesn't make any sense. So that means that I made a mistake. And I am gonna go figure out my mistake right now. So bear with me. That's that. X is our long side. And then if I look at this triangle, X is my hypotenuse. 12.8 is my long side. So, oh, wait, no. So I could do, Oh, okay. Yeah, I had no business using 4 because I don't know the short side of my big guy. That's my problem. So I can do 12.8 goes to x, and then I can do x goes to 14.05. It's a little wonky. So 12.8 times 14.05, and then I'll take the square root of it because we get x squared this time. And I got 13.41. So that number is absolutely a legal number. We haven't talked super much about this, but that's your right angle, it's your biggest angle. That means that has to be the biggest side of this big triangle. So this can't be bigger than it. So 13.41 would be at least in the legal range. There's a chance that I didn't completely screw it up. And I am just gonna quick double check. And let's see. Let's go to the next. Let's just make sure. Okay, yeah. All right, well, hey, I hope this was helpful, and I'll see you later. Bye.